Aloha, Richard Halverson here. This is ITS148, and I'm going to share my screen right now. Well, I know what I'm doing. Okay, so today I'm going to cover, let's see, the last video, the last video that covered the textbook stuff was, it talked about recursion, chapter 15. So today I'm going to go over a couple of the last two labs in chapter 15. This one is pretty easy, so I'll let you work on that. And so let's try this one here. If you have any problems with the 15.7, just email me and I can help you with that. All right, so make sure I'm in the right. And this is a recursive program. Okay, write a program that lists all ways people can line up for a photo, all permutations of a list of strings. The permutation will read a list of one-word names, then use a recursive function to create and output all possible orderings of the names separated by comma, one ordering per line. So let's say the input is these three names. And so we will start by printing out Julia first. I guess it's going to print out this one, and this one. And then we're going to print out this one, and this one. And then we're going to print out this one, and this one. And then this one, I guess we do, yeah, then Lucas, Mia, and Julia. Anyway, and so we're going to write a program to do that. And we're going to start with this. And I think I'll do the replet thing so you can have access to some of the code. And this is 148. And I'm going to create a new project called this. This. This is what it is. Okay, right? Okay. If you're seeing this, that means you get to test a new workspace design. It has a few key differences we want to show you. It's got a, oh, nice. I guess I can look at this later. All right. And let's start with what's in here. All right. And to do is to implement a method to create and output all permutations of a list of names. I gotta see what's new here. This looks like the solution to me. Aha, that was the solution. Oops. Did I do this before? I didn't do this one. I must have done this before if that solution was there. Let's see real quick.
You know, I ran that solution and it didn't get up to 10 over 10.
Oh, you ran this one?
I think so, or I got it from like last spring from the video.
Oh, maybe that's, you think that's why this is here? Oh, okay. Oh, okay. So you're saying this is not complete?
It didn't work for me. Getting the comma at the end of the last variable was tricky.
Oh,
I mean, getting it away. It was,
Oh, getting rid of it. Okay.
Yeah.
Oh yeah. Okay. Uh, well, well, I'm just gonna try to run it and see what happens. Run. And I'm supposed to enter in some names, I suppose. Where is it asking? Oh, here. What? Oh, I see. All right, so I'm gonna put in these names. Copy. Paste. And
It does work. Okay.
so you had trouble. Okay, so when you ran it, it didn't have it has the comma at the end here, I guess.
Yeah.
Okay, so so maybe in here, is it so you might have, this line might be not quite right then.
Yeah. I kind of tweaked the code. So that was the problem I was having with it. I don't know if it was this exact one.
Hmm.
Obviously not.
Hmm.
Thanks though.
Okay, so
Oh, I remember with this one, it wasn't giving the mix. Like the variables weren't changing to match the what the Zybooks, grader was expecting. They're out of sequence.
oh, oh really?
I think so,
Um,
if memory serves.
okay, well, I tell you what, I am going to all right, well, I tell you what, I'm gonna let's see, how far did, okay, right, gee, it's the whole, we're supposed to write this whole thing. Okay, so well, okay, I'm gonna take this here and paste it in and see if it works. Wait, did I start recording? I did, right? Yeah, okay. Copy, and I'm just gonna paste that in here. And I'll just gonna see if we get all the points. Well, all right.
Awesome. Thank you.
Okay, so let's just go through this now, just real short, real quick. So it's like, um, so we read in a name, a list of names, we and then we have this permanent list, which is empty. And I guess we're gonna fill this perm list with all the permutations from name list. And so print all permutations, that's this. And so this is the list that perm list. It's a list, so it's mutable. Print perm list, new perms. Here we're appending it on, and then okay, so okay, well, yeah, these recursive programs are hard to follow. I'm gonna see if the if I can get the debugger to work. And I'm gonna try to add some breakpoints. I'm gonna add some breakpoints. So we read in, we come in here, and we if size is equal to 0, then we do this. Otherwise, okay. So I'm gonna if the size of the name list is equal to 0, then we're done. Then we've exhausted all the names in name list, and then we can print it out. And that's what this does. This is printing it out. Otherwise, we're going to go down here and we will make a copy of the current perm list, and we will append onto that the next name, and then I guess we go through iterations. Okay, so I'm gonna put a breakpoint. I guess I'll put a break. How do I put a breakpoint? Click on the line number. All right, I'm just gonna put a breakpoint here. Oh, can I click breakpoints? Is this gonna work? There's where I click. Okay, that's the problem. Okay, so I don't click, I click just to the left of the line number. Okay, so I'm gonna see, let's put this down. Let's put a breakpoint here so we can see what the value of size is. And then we're gonna decide whether we're gonna go into this area or this area. And let's put a breakpoint here. Oh, here, can I put it there? And that here, there, I don't know, and here or something. All right, let's just see how this works. Okay, so now I'm gonna I'll hit run, I guess. Run. And now it's waiting for some names. I'll shoot some. All right, so we have stopped at this. Call stack. We must be at line 4. Print all. In line 4 of print all permutations. We're at line 4 of print all permutations. Size is equal to 3. Perm list is empty. Comes in. This is name list right here. Name list is a list with these 3 names in it. Perm list is empty. This thing right here is empty. And size is equal to 3 though. So size equal to 3. So is size equal to 0? No. So it's going to skip down to here. And so I guess I can do next step. Okay, now it's down here. And perm list is still that, perm is still that. And then we're going to go to I'm just going to hit next step here. And now we've got I equal to 0. And new perms, nothing. Let's go to here. So now we've got a variable new perms. And new perms is empty because perm list is empty because it just made a copy of that to that. And now we're going to be appending the first. So let's click here. And now new perms has the first name here. See that? Now new perms has Julia in it. And now let's go one more. And now we can see that new names. Oh, now we have a new variable called new names, and it's just a copy of the names list. Okay. See, it's a copy of the names list. And then we're going to pop off the first one because that's in here. The first one is in new perms. So this looks like this pops off the first one of new perms. So I'm going to click one more time, and lo and behold, now new names just has 2 names. New perms has 1 name, and then we're gonna call call ourselves again here. So let's just go click, and boom, now we're up here again. And this is the call stack, and see, we've this is the old instance, or this is the older instantiation. That's same as instance, but it's got more syllables, so it sounds more impressive. This is the previous instantiation of this method. Now we're into the new one. We're into the next one. So that's why we're up at 3 here. So we're here. These are the old, these are the variables from this instance down here, and then these new ones are variables from this instance. See, this is a recursive program, so there's going to be a bunch of instances of the same method being executed all at once, because it's calling itself. So let me just click again, and we get now we're at this if statement, and size is not equal to 0 yet. See, size is 2. Go down here. I go down here. Going to create another one. Another new perms, another new names, and we're going to pop off that one because, and then we go back to create all permutations again, and so now we've got 3 of them. And what's going to happen is this is going to keep on going until it's called, and size of name list here is going to be 0. And once it becomes 0, then I guess we can start printing everything out. So this goes through here again. And now we're going to call ourselves again. And create a new size. And now size is equal to 0. So now this stuff is going to execute. And I guess I could put some breakpoints in there, but I'm not gonna. Okay, so now we're executing this loop up here. See, that's, so now we have another I here that starts out at 0, and we're gonna loop, and we're gonna start printing some stuff out here. Going through the i's equal to this, now I is equal to 2, and now this thing prints out, and we're back, and we're done. So now we return, and I think we go back up here and we loop and call ourselves again. Anyway, this probably wasn't a very good example of a program to demonstrate the debugging features of this replit, but it's good to learn about the debugging features, because when you these are the kinds of tools you use when you're writing big programs, and it's a bunch of people getting together, and they want to make sure all their code works, and you're passing data back and forth, parameters and arguments and all that stuff, and stuff's not working, and you have to show somebody, no, your code's not working, here, let me show you, and then you can step through this and see where everything is, and if we were to follow this all the way through, we would see that the stack grows. If here we just go from breakpoint to breakpoint. Oh no, here we go from breakpoint to breakpoint. And we just see that this print all permutations, this thing gets called, and it grows, and it gets shrinks, and it grows, and it shrinks, and it grows and shrinks until all the possibilities have been exhausted. So anyway, you have the code here. It looks like it works. So why don't you, so that's good. Why don't I guess I'll just publish this. And we might as well go on to the next one. All right, here's Fibonacci sequence. I think this is a pretty easy one. Oh, let me make sure I load the default template. Okay. So use recursion, do not use loops. Okay, so we have to write the Fibonacci sequence begins with 0, then 1, then all subsequent values are the sum of the previous two. So we started with 0 and 1. So, and then after that, this one is actually the sum of these two. And this one is the sum of these two. And this one is the sum of these two, and so on. This one is the sum of these two. And so what we are supposed to write is a method called Fibonacci, def Fibonacci, that takes in an argument, that takes in a parameter n, and then it returns what that Fibonacci number is. And so Fibonacci 7 is equal to 13. Well, let's make sure we get this right. This must be 0, Fibonacci 0, Fibonacci 1, Fibonacci 2, Fibonacci 3, 4, 5, 6, 7. Okay, so that's what it is. We start counting at 0, and Fibonacci of 0 is 0, and Fibonacci of 1 is 1. And then after that, Fibonacci of 2 is Fibonacci of 1 plus Fibonacci of 0. And Fibonacci of 3 is Fibonacci of 2 plus Fibonacci of 1. And Fibonacci of 4 is Fibonacci of 3 plus Fibonacci of 2. So we have Fibonacci here. In fact, I think I'm going to go over and start another one of these replit thingies just for everybody for all the rest of the people that aren't here. Let's see. I got to go back to my here or something. I don't know. What? Where do I go? Here? Here? Where do I go? Oops. Oh, I didn't mean to do that. What? What did I just do? I'm missing I'll just go home here. Oh, save changes? That's okay. I don't care. All right, go back to Teams, go back to this and create a new project. And this time I'm going to call it this. Python. Okay. And let me take this, put it here. Okay, so Fibonacci of, okay, so if n is less than 0, then the input's wrong, so it's not going to be anything. Error. Return -1. The Fibonacci of anything less than, so I'm just going to say that. That doesn't matter. Okay, so that takes care of all this, because we're going to want to cover all the integers. In fact, we don't even need that. But all right, if n is equal to 0, then we know that that is the Fibonacci of 0 is 0. Okay, so I'm just going to return 0. If n is equal to 1, then I want to return 1, because Fibonacci of 1 is 1. Okay, we don't have to do anything. So return 0, return Fibonacci Fibonacci of, okay, so it's going to be 2 or greater. It's if it gets all the way to here, if it actually gets to this point, then we know that n is equal to 2 or greater. Okay, so we want to return Fibonacci. Okay, so and Fibonacci n is equal to Fibonacci n minus 1 plus Fibonacci n minus 2, right? Because Fibonacci 2 is equal to 1 plus 0, or Fibonacci 1 plus 0. Fibonacci 10 is equal to Fibonacci 9 plus Fibonacci 8. So Fibonacci of n is equal to Fibonacci n minus 1 plus Fibonacci of n minus 2. Maybe. Let's see. So I'm going to run this. Oh, and I'm going to say, I'm going to put what I want. Enter a an integer. Okay. So I'm going to say run. Enter an integer, 7. Very good. How about 50? It might not finish. The problem is see, it keeps, if we were to be tracing this, we'd see the stack go because it's got to go all the way down. The stack has got to be at least 50 deep, right? Because it's calling n minus 1, n minus 2, and n minus 3 all the way down. So I don't even know if this is going to finish. In fact, can I just stop it here? Stop. Okay. Let's try 20. Oh, okay, that's pretty good. Let's try I'm going to put a breakpoint right. Oh, console. No, what do I do? Debugger. I want to put a breakpoint right here. Okay, I'm gonna see what happens when I run this now. Enter a number. It's executing this, and I'm gonna say 10. How about if I put 10? Enter. And the call stack, we're calling Fibonacci once when n is equal to 10. And then we're gonna, and I'm just gonna skip to the next breakpoint. Boom. Now we're calling Fibonacci again with n equals 9. And then again with n equals 8, 7, 6, 5, 4, 3, 2. And now we're going to start getting some answers because we're reaching the bottom here. And we got, now it's 3. Wait, now what happened? Oh, why is n 3? I'm sure n is supposed to be 3, but I just not thinking right now. All right, what's next? 2. 4, 3, 2, 2, 5, 4, 3. Definitely a pattern here. And we could probably see more if I did something like this. I'm going to say fib n minus 1 equals this. And then I'm going to say fib n minus 2 equals this. And then I'm going to say return, no, I'm going to say fib return equals fib nm1 plus fib nm2. And then I can just say return fibret. Okay, so that way I'm breaking it apart so we can see the different calculations, see these numbers as they come back, see them added together, and then see that returned. So what do I do now? I'll press this. Oh, I have to stop it. Okay, now I'm going to start it again. And I'm going to make my breakpoint not there, but here. All right, run. Asks for enter an integer. I'm going to enter 10 again. I guess I wouldn't have to enter 10, but I'll just enter 10. And then, did I press run instead of this? Oh, well. Anyway, for some reason, we're all the way up to here. What's n? N's equal to 2. Did I? I don't think I stopped it at the right place. N's equal to 3. It's equal to 2. Let's see. How do I stop it? How do I take out the breakpoint? Can I stop this thing? How do I stop this thing? I'm not sure. That's how I stop it. I want to take this breakpoint out. Okay, I'm just gonna run this once now to see. Okay, enter. I'm gonna do 8. Okay, Fibonacci 8 is 1. Okay, so now I'm gonna hit. I'm gonna put a breakpoint here. No, I'm gonna put a breakpoint here, here, and here. And then I'm gonna start it. And it's gonna ask me for an integer, and I'm gonna say 8. Enter. And we've stopped here. Okay, so we've got the 8. We've called it with start num is 8. Is there a start num? Guess not. Yeah, there should be a start num someplace. Start num here, 8. Start num is 8. And then we've called it and we've stopped at this first breakpoint, which is at 9. And n is 8. And let's go to the next breakpoint. So we've got fib. Where's fib num? Are we at 9? Why am I not seeing? Oh, function variables, maybe. No. Special variables? No. I'm wondering why I'm not seeing these numbers here. Well, let's just click through some more. Oh, there they are. Oh, I know why we weren't seeing them, because we called Fibonacci again. We called Fibonacci again, and it was still calculating what that is. And then finally, when it does get a value, which it did right there, then it returns that value. Okay, so so now we have a fibnum. We have fibnum1. Okay, so now fibnum1 and fibnum2 are both 1. So this must be, you know, where. So now n is 4. Fibnum1 is. Oh, I see. We're going back down again. Back down to 0 and 1 again. Well, anyway, okay, so let's see if this works. I'm pretty sure it'll work. Oh, we have to define this whole thing. Copy. Right here. I'm pretty sure this will work. Uh-oh. Oh no, that should work. Okay, it did work. All right. So anyway, so I guess I'll publish this. Oops, I didn't publish it, did I? All right. Okay, so that's those two. What time is it? It's 2:15. I still have a half an hour left. So I did the recursion. Are there any other? Okay, so all right. So it looks like I've covered all these. So why don't so I think I'll start chapter 16, okay? Let's see, how are we with chapter 16? Okay, there are not in chapter 16, there are not any challenge activities. But there is the 16.5 middle item, but 3/4 of the people have gotten that done. But binary search, the last one, you need to be able to do this one, to be able to do this one. I think to be able to do this one, you need to do this. Is that right? Yeah. So why don't I do this one? All right. So what we're supposed to do is loading the latest submission. It's not doing that, is it? Okay, so binary search can be implemented as a recursive algorithm. Each call makes a recursive call to 1/2 of the list the call received as half of the list of the call received as an argument. Complete the recursive binary search function. Okay, so the parameters are a list of integers and a target integer and lower and upper bounds. Okay, and then there's going to be a return value. So the algorithm. Okay, so and then we also want to keep track of recursions and okay, so okay, okay, so we'll put the global variables there in a moment. Let's just let's get binary search working first. So what we have coming in here, this is a list, and this is this is the value of the element that we're looking for, and we want to return the index of the target. So if this target is in this list, then we want to return the index of this target. And we aren't looking at the whole list. We're only looking between the lower and the upper, probably not including the upper. So what we want to do is we want to first of all, we want to figure out what there's this upper and the lower and the upper, and we want to find the middle of that. And then we want to test to see if the target would be less than the middle, or if the target would be greater than the middle. And the reason I say would be is because we don't know if the target's in there yet, but if it were in there, that's where it would be. We will and of course the fact that it's recursive means we keep on doing the same thing each time, cutting the size, the distance, the size of the list that we're actually searching each time gets cut in half. So let's figure out what halfway between lower and upper is, and so I'm going to call it and that can be the index that we're looking for. So let's just call it index is the upper. I guess it would be upper plus lower divided by 2. Now we want to make sure that it's add these two quantities together and divide by 2, and then we want to do an integer divide, and in Python we do 2 slashes to make it an integer divide. And now we have some number that is some index. Okay, this is an index, this is an index, and this is going to be halfway between these two numbers. And then we want to look and see if target is greater or less than in nums. So first let's see if we found it. I mean, we could get lucky and just have found it. So I'm going to look and see if nums of index is equal to target. Okay, if that's true, then we're done. And we can say return whatever this index thing is. Okay. If it's not true, then we're down here. And we want to find out if target we want to find out if target is less than the index or greater than the index. If the target is less than the index, then we know that the target is going to be in the lower half of this lower upper set list. It's going to be in the lower half of it. So if this is true, then we want to set upper equal to index minus 1. Okay, so let's pull up a whiteboard. I was doing this last time. Can I clear the canvas? Yes, okay. Ugh. All right, so if we have like 2, 3, 5, 8, 11, and we're looking for let's say we're looking for 4. No, let's say we're looking for 4. That's the target. The first thing is and we're going to start with lower is equal to 0, and upper is equal to 0, 1, 2, 3, 4. And then so middle is 0 plus 4 divided by 2, which is 2, 0, 1, 2. So 0, 1, 2. So middle, the index would equal 2, which is pointing to this one. And if we're looking for 4, and index is 5, and we're looking for 4, we know that that we got to look in the lower half. Okay, we know it's not 5, so it's going to be, so if 4 is in there, it's going to be in the lower half. If we were looking for 7 and 5 was in the middle, then we would want to look in the upper half. We would skip 5 when we want to look at from here to here. And so we would and then for 4, but we're doing 4, so the next time we're gonna take the upper half and the lower half, and it'll be 0 plus 1 is 1 divided by 2 is going to be 0. So the next index is going to be 0, and 4 is going to be greater than 2, and well, we'll get there. So I just wanted to show you that part. Okay, so if the target is less than index, then we have a new upper, and upper is equal to index minus 1. Or okay, else if we get here, then we know that that index is less than target. Index is less than target, so we want to say lower index is less than the target, so we want to say lower is equal to index plus 1. And then we're going to call binary search again. So and binary search is going to return an index, right? So return I'm not doing this right. Target is a value. This is a value. If this has got to be a value, so this has got to be this. And this, okay, so that right, okay. So if target is less than what the value is at that index, then we want to bring the upper one down. If the target is not less than, if it's greater than, then we want to bring the lower one up to index plus 1. And then we want to go ahead and search binaries. Then we want to call ourselves again with a new set of parameters. So binary search nums, comma, still target, and a new lower and a new upper. I'm pretty sure that's right. All right, so that is so that should get us the index of the target value if it exists. If not, it's gonna return -1. Where does it return -1? It's possible. Okay, so if we're at the end and we can't find it, then what's going to happen is this is going to end up being lower than this, because if we look at this thing, the index the index, see, yeah, the when upper gets set to index -1, index will already be equal to upper. So upper will end up, let's see, index will already be equal to lower. So, well, anyway, they'll cross. Upper and lower will cross. So if upper and lower have crossed, then that means that if lower is, it'll be greater than, if lower is greater than upper, then return -1. Else, otherwise we're here and we want to return this. Now, I don't know if this is right, so I'm going to just try it, see what happens. Now, I don't have the recursion stuff in there, but I do have the index stuff in there. So I probably won't get this right, but I want to see if I get this right. And I'm going to submit, see what happens. Oh, my program produced no output. Did I not finish? I must not have finished. So no. Target value. Start off with that, and then print that. Module. Well, recursions is not do we just have problems with that? All right. So I got to put these global things in here. Let me put this in here. Recursions equals 0. Comparisons equals 0. And they're global. Global recursions and global comparisons. I want to see what happens now. Okay. It looks like my index is correct. All four of them, or whatever it is, for all four of them, index is correct. It's just that we aren't counting recursions and comparisons yet. We're not counting recursions and comparisons yet. So to count recursions, every time we call binary search, we are recursing or whatever. Where would I put that? Every time we enter binary search, we are doing recursion. So I'm gonna recursions +1. And what happens now? Well, I've got the recursions. I'm gonna let you figure out the comparisons. And looks like we're doing a comparison here. We're doing a comparison here. So I don't know. What is it supposed to be? 3, 5, 7. Ooh. Okay, well, this is a comparison and this is a comparison. This is a comparison too. I don't think you count all of them, but you can fiddle around with it, adjust it, and get the right answer. And this is one of those things where when you get the right answer, you're not really sure how you ended up with the right answer, because this is kind of ambiguous, you know, counting comparisons. Counting recursions is pretty, you know, pretty accurate, but counting comparisons, it's because well, when this comparison takes place, and if it's true, then it's not going to do this one anymore. But if this comparison, if you do this comparison and it's false, then you're going to do this comparison. Okay, so that's two, and it depends on whether this is the case. So that's why you can get kind of messed up sometimes. And then at the very last time, at the very end, you're going to do, this is going to be um, if target is not in the list, then this is going to happen just once. But anyway, all right. So it's 2:30. I guess I can keep moving here. What's next? That was binary search. Okay. Let's see what's chapters sorting algorithms here. 16. Let's see how we've been doing on chapter 17. Oh, insertion sort. Well, I could do insertion sort. We got 10 minutes. And I think you got to do this for a lab anyway. So let me make sure I'm running default template here. Okay. Okay. Insertion sort. The script has 4 steps. First, it reads a list of integers, doesn't have any, and then it outputs the list, and then it does an insertion sort on the list, and then it outputs the number of comparisons and swaps performed during the insertion. Okay. So steps 1 and 2 are provided. That's nice. Implement step 3 based on the insertion sort algorithm in the book. Modify insertion sort to do this. Okay, so insertion sort in the book. Insertion sort. Is that it? All right, okay. This is it right here. I'm going to copy this. I'm going to go back to this. All right, let's do one of these. Oh, did I stop. Did I oh, I published this already, huh? Oh, whatever. Okay. Let me, oh shoots. Let me go back to Replit. And I'm gonna put this one in there. Copy. Teams 148. Oh, I did it already. But I didn't publish it? What does this look like? Wonder why this is here. So you don't recall my doing this before. It says fall 2022.
I think we did descending sort.
Oh. Let's see. Let me just quick see if this is how close this is to the solution. Um, Well, let's just see if this is a solution. This looks like it's, oh, wait, are we supposed to do some, oh, we're supposed to print this out after each time, huh? I wonder if that's done here. Let's run this and see what happens. Okay, I don't print it out after each time. All right, well, let's see. Did I publish? I didn't publish this. I'm going to do it again. I'm just going to do it again so you can see what's going on here. I'm going to go back out. Can never figure out how to go back out. All right, I'm gonna I'm just gonna delete this project. How's that? Yes, delete this project. Okay, now it's gone. Okay, create project. Title, is it still, no, it's not there. Copy, paste, and Python. And over here, I'm gonna put this. Oh, I see. Copy, paste. Okay, and let's, oh, really, this is, what does this do right now? Oh, that's all it does. Okay. So, step one, read numbers into a list. It does that, reads the numbers. Step two, outputs the numbers. It looks like the numbers are integers also. They're just they aren't even numbers, are they? Oh, never mind. Read nums. What's read nums? Okay, it is. They are integers. Reads them in. I'm gonna put something here. I'm gonna put enter list of integers to sort. And then I print them out. This puts a space, changes it back to a string, prints them all out. And then the third one is to do insertion sort. Okay, so insertion sort. We start out with count the comparisons and swaps. Okay, first I'm going to do the sorting. So from I starts out at, I'm going to pull up this thing. So let's say we've got, where's my, oh, 3, 2, 1, 5, 9, 8. And we start out with I in the range of 1 to the length of numbers. So I is going to start out at 1. I'll just put here. I starts out at 1. And we're talking indexes here. So we're pointing. So I starts out pointing it to that one. And then we say J is equal to I, and we go while, can I do this? No. Boy, this is really touchy. okay, so this starts out. This starts out with j equaling I. So this j is now equal to I, and it tests to see if j it tests to see if the number at j is less than the number at j minus 1. So we're looking to see if the number at j is less than the number at j minus 1. It is. So we're going to swap them. We're going to swap the two. That's what this does. This is not working very well, is it? And I don't need this over here. So if it's true that that numbers of is j less than the one below it? Yes, it's j less than the one below it. It is. So we're going to swap them, and we're going to end up doing. So 2 is going to be here and 3 is going to be here. Okay, so we've done that, and then j gets decremented by 1, so that means j is the blue one, so j gets decremented by 1. And then it goes back up here and says, is j greater than 0? No, j is not greater than 0. See, this is 0, right? This is 0, this is 1, this is 2, this is 3. So j is not great. J is equal to 0. So then we're done with the while loop, and we go back up to the top again, and then we increment I to the next one. I now is going to be I is now this one, and so I is now equal to 2. And then we go down here and we said j equal to I. So now j is equal to this. And we see is the number at j less than the number before it? Is the number at j less than the number before it? It is. So we got to swap. So we're going to swap. Let's swap 3. 1 and 3. Oops. So now it's 1 and 3. And right here, j gets decremented to here. Okay. And then we go back up to here again. And is j greater than 0? Yes, j is greater than 0. J is equal to 1. This is 1. And is numbers of j less than the one before it? It is. So we got to swap again. So now we're going to take this, and we're going to take this. I mean, this is a 1 and a 2. And great. Then we're going to decrement j again. And so j gets decremented by 1. And now j is pointing to here. And is j greater than 0? No, it's not. So we're going to go back up to the top again. And now I gets to be equal to 0, 1, 2, 3. And this is going to be 3. And j is going to set equal to I again. And is 5 less than 3? No, it's not. Okay, and we can stop there. See, because if 5 is not less than 3, then we know 5 is not going to be less than 2 or 1 either, because the lower part is sorted and they're smaller. So this is what makes the while loop stop, because 5 is not less than 3. 5 is greater than 3. So then we go back up to here, and I is incremented to 4. So I is now 4. 0, 1, 2, 3, 4. I is that. And we go back to J. And J is now equal to 9. And we go down here. Is 9 less than 5? Is the number at J less than the number at J minus 1? No, it's not. So this is false. So we end up incrementing again. We go back up to here. And we increment I to 5. 5, 0, 1, 2, 3, 4, 5. And then we set J equal to I. And we look, is the number at J less than the number before it? It is. So we have to swap them. So 9 and 8 get swapped. 9 and 8. And then this gets decremented. Is 8 less than 5? No, it's not. So we're done. And so we're done. So then we go back up to the top here, and I gets incremented, and we see that I now is greater than the length, and so we're done. So this thing is done. So that's how bubble sort works. No, insertion sort works. And so what are we supposed to do? We have to do this, and we have to count comparisons and count swaps. Okay, so let's count some swaps. This is a swap. We'll swap right in there. Okay, do we have to do this? I guess we should comparisons and swaps, huh? Comparisons equals 0, and swaps equals 0. And they're all inside here, so we're going to do some globaling. Global comparisons and swaps. And let's see, when we go here, it's a swap, so I'm just going to count swaps right here. What the heck? Swaps plus 1 plus equals 1, so incrementing swaps. Comparisons? I don't know. This looks like, I think they mean just here. But the thing is of course there's a comparison that goes on in here, because we have to check to see if whenever this is incremented, we have to check to see if we're done. So that's going to be a comparison. And you might even think that there's 2 comparisons inside here. But anyway, let's see. And then we're supposed to print out after each iteration of I. When this is done, when this while loop is done, we want to print out that iteration. And is there a print nums? Print nums. So I'm going to write here, right in line with here, when this while loop is done, before we go back up here and try again, I'm going to print underscore nums. And what am I going to print? I'm going to print numbers, I guess. Yes. Yeah. Just like this. All right, let's see what this does. Ooh. Indentation error on line 19. Huh? Oh, really? Okay, I'm gonna put that there and that there. How's that? Okay, list of numbers to sort. I guess I'll just try these again. Oh, that looks kind of funny, doesn't it? Print. There. Well, it's getting close. Let's see what this looks like compared to, just break this off and put it over here. And what does it look like? Tooth. That's pretty close. Oh, I didn't print out comparisons and swaps. Okay, I guess I should print out comparisons and swaps then. Oh. Print. Comparisons. Comma. Comparisons. Comma. Quote. Backslash. Swaps. Quote. Comma. Swaps. I'm going to see what this does. Well, doesn't look right, does it? There must be some more swaps, some more comparisons someplace. Let's see what the solution says. Hmm. Um, hmm. Oh, okay. So I'm just gonna tell you what's different and then you can fix it. But basically what happens is uh, if J is greater than 0, then if this is true, then do these things. Um, while, oh no, it's never mind. It's got to be inside. Yeah. Oh yeah, this has got to be inside. Okay. Okay, so if, all right. So this checks to see so this separates it out. This separates out the number of comparisons. So you can say that there's another comparison here. And so this is another comparison. If this number is smaller than the number before it, then we have to swap. But if this number is not less than the number before it, then we know that we're done looking. Then we know that this while loop can end, because if this number is not smaller than the number before it, it's certainly not going to be smaller than the number before. It's certainly not going to be smaller than the number before that, because it's kind of like, see, this the last one here. See, we're testing the 9 and the 5. Okay, so let's do the last one. So we're here, and J is J is 5, and if the number at J is less than the number at J minus 1, then we swap. So it's swapped. Let's do a different example. Let's say we're so we've just swapped. Okay, so we're here. And J is 4, and is the number at J equals 4 less than the number at J equals 3? No, it's not. Now, if this number if the 5 is not less than 3, then we know the 5 is also not going to be less than the 2 or the 1. So as we're checking numbers, as we're swapping numbers going down the line here, once we hit a number that we're not going to swap with, then we know that we don't have to go any further, because any further we go, those numbers are only going to be smaller. So what that means, after all that, what that means is, here, if this is not true, then we can exit. And so a break, it's called break. So then we are done with the while loop. See. So then it breaks out of the while loop, and that breaks out to here, and it prints. So I'm going to see what this does. So we've split out the comparison. Oh no, I got to add one more. Oh no. So this thing is going to count this comparison, and this one is going to count this comparison. And once we get to the point where this is false, then we know we're done. So that's why we can break out of this. Let's see if this works. Whoa, we're off, aren't we? Yeah, I want to see what's different here. Oh. Apparently we don't count this. I don't think we count this for some reason. All right. Well, anyway, that's pretty close. I'm just going to publish this and not say anymore. So, all right, it is. It's late. So anyway, we've done we've covered a few extra labs today, and see you next time. Hope
Thank
this
you very much,
helps.
Dr. Halverson.
All right.
Appreciate it.
Thanks.
Yep, you're welcome.
Bye.